In this video, I will demonstrate how to find and segment nuclei. So for this, we'll add the Find Nuclei step. First, specify the channel. In this channel, our host staining is in blue, so that will be in channel 1. The fastest way to find nuclei is through our template matching. But you can also use a histogram-based methodology in local peaks, as well as a deep neural net. This deep neural net will be slower, but it perhaps is more accurate, particularly with dense nuclei. For the template matching step, you first choose a reference. We have references based on fluorescent nuclei, as well as various transmitted light references. That would be our focused and over-focused and under-focused templates. These will depend on the state of your nuclei. For this example, we're going to focus on fluorescence. So once I've selected that, I then will go and select the size of my nucleus. So I'm going to use this 100 pixel by 100 pixel, as we've previously determined using this measurement tool, that is about the size of these nuclei. Once I know the size of those nuclei, I then can say where I want to measure these. If you've previously defined a mask, you can use this within. Right now, all I have, this is a first step, so I can only say within image. With that, I have some advanced options. First is a luminance threshold. I can use my pixel spy to determine the luminance of my background versus my foreground. With this, I know my background is about maxes out about 300 AU, so I can then say I'm going to call my nuclei anything above 400. We also set a contrast threshold. This is optional, and we can speed up things slightly by unchecking this box, but it's useful as a further way of filtering out these data. The next option is this confidence threshold. This is basically how close is your nucleus to resembling what the template is. Generally, the less round your nuclei and the less regularly shaped, the lower your confidence is. The lower your confidence threshold too much may find erroneous values. This final setting will basically say how close are your nuclei together and how much overlap is being tolerated. I'm going to leave these be for now and just run this one step. So this button will just run this current step as is without running any other steps. So this has been run. So what the output of this is our bounding boxes. So those bounding boxes are going to find the XY center here. So as you'll notice, these bounding boxes seem a little too small for these nuclei. And they are double counting here. So there's two changes I'm going to make here. One is I'm going to increase the size of my reference, and I'm also going to be less tolerant of overlap. I'm now going to rerun it, and we'll see the effect of those changes. That looks quite a bit better. So now I'm going to go on to segmentation. So the major difference between detection and segmentation is detection only finds the XY center of objects. It's drawing these boxes around those objects, as we're essentially saying this is the XY center, and given the size of this reference, this is where we're going to look for those. So whereas segmentation is basically saying where are the boundaries of this? As with detection, there's several ways we can do this. One, again, is through a deep neural net. So this is using our inbuilt AI models to define these borders. The other is threshold-based, and thresholding basically uses the intensity to find this. There's also watershed, which uses thresholding, and then it also attempts to find the border by looking for edges. We're going to use threshold-based here. With threshold-based segmentation, there's several options. This first option automatically finds the mean, median, and max of the image and uses that value to make a threshold. Manual is basically going to say, I know the boundary at which things are objects and not objects, and I'm just going to type in that raw value. Otsu uses the histogram to detect the value at which it's putting that threshold. For both Otsu and the 4M methodologies, you can do that on the field of view level or that single object level. The reason why you change these two things is if you chose object level if you have dim objects that you want segmented, whereas population level is for more if you have uniform intensity. I'm going to bias this a little bit, which will make it a little bit less restrictive in its mask, and then I'm going to run this step. Now I'm going to use this run button. So what this run button lets me do is run the entire protocol, either on a single field of view basis for just this well, on a single field of view basis for an entire well, as well as just that whole well, field of view for entire plate, or the entire plate, all fields of view. I'm just going to run on this single well, this single field of view. Now this seems to over-segment. And again, so now I can just move my bias slider over a little bit to now make that a little bit less restrictive. So as you can see, I now have segmented nuclei.